Assalamualaikum warahmatullahi ta'ala wabarakatuh. To my fellow examiner, Dr. NURSALBIAH and Dr. FARRAHSHAIDA, I am Luqman Hazeeq bin Ahmad Izuddin, the FYP2 student under the supervision of Dr. SUKARNUR bin ABDULLAH, and today I would like to present my project, which is entitled Design and Simulate an Automatic Bottling Packaging Machine. This project is the collaboration between UITM and Izuddin Berhad, or known as ESSP, which is the mineral water bottle company that is based at Simpang Renggam, Johor. The size of mineral water bottle produced by ESSP are 250 ml to 500 ml and 1.5 liter, which have been monitored by 10 workers. In this project, I will focus more at the packaging section, where 24 mineral water bottle is manually packaged by the worker. From this project, there are 3 problem statements that can be determined, which are the failure of determining the working principle of the automatic bottling packaging machine, which can transfer the bottle into the box without the human interference. Second, the improper and failure of designing an automatic bottling packaging machine, which can replace the manual process into automation process. And third, the failure to conduct the simulation process on the automatic bottling packaging machine. Therefore, from the previous problem statement, we can outline the objectives for this project, which are to identify the process of transferring the mineral water bottle into the box by the automatic bottling packaging machine, which can replace the manual work. And second, to design and simulate the automatic bottling packaging machine. The scope of work which has been conducted throughout the whole project are: first, the industrial visit at the production plant; second, conduct research on the automatic bottling packaging machine; third, selection of the correct devices and design which will be used in the automatic bottling packaging machine; next, the determination of the working principle of the machine; and lastly, design and simulate the machine in the computer-aided design, which is CAD software. As you can see here, this is the flow of research which has been conducted throughout the whole project. First, industrial visit at ESSP, and after that, determine the problem statement and identify the working principle and device which will be used for the machine. And after that, the design must be drafted. And after the design has been drafted, it must be revised with the supervisor. If the supervisor agree with the design, the next process, which is make a CAD design using the SolidWorks software, must be conducted. But if the design is disagreed by the supervisor, we must do a correction by identify any potential problem which can affect expenses, safety, reliability and quality of the product, and after that fix the design to overcome the problem which might be occur. And after the make a CAD of design using the SolidWorks software has been conducted, therefore the last process is conduct a simulation on the prototype of the machine via the motion study feature in the SolidWorks software. In this flow of research, you can see here the first objective is shown, and the second objective also is shown in the flow of research. As you can see here, this is the industrial visit at ESSP. The purpose of the industrial visit are to determine the axis dimension of the floor plan for the packaging section. Second, to determine the dimension of the bottle and box conveyor. And lastly, to measure the production time in the packaging section. As you can see here, this is the bottle conveyor and box conveyor at ESSP, and this is the manual packaging by the human operator. I will show you the video of the manual work by the human operator. The bottle is flow throughout the bottle conveyor and manually packaged by the human operator into the box. From the site visit which has been conducted at ESSB, the dimension of the floor plan for the packaging section which is available at ESSB was measured. Therefore, the dimension of the automatic bottling packaging machine must not exceed the existing available free space. As you can see here, from the exist bottle conveyor line to the office is about 1630 mm, while from the bottle conveyor line to the wall, the exist dimension at ESSB is 1190 mm. From the site visit at ESSB, the dimension of the exist bottle conveyor was measured. The height for the bottle conveyor is 1667.81 mm, while the width for the bottle conveyor is 155 mm. The length for the bottle conveyor is 2370 mm, and the speed of the bottle conveyor was calculated, and the speed for the bottle conveyor is 0.15 meter per second or 150 millimeter per second. From the site visit, the box conveyor also been measured. The dimension for box conveyor for the maximum height is 691.54 mm, where the box will travel along the inlet of the box conveyor, and the width which was been measured is 550 mm. From the site visit at ESSB, the duration for the 24 bottle manually transferred by the human operator into the box take about 16 seconds. In this slide, I will show to you the existing automatic bottling packaging machine in the industry. The model of the automatic bottling packaging machine is 939 APT Versatron Active Product Transfer Case Packer, which was manufactured by Standard Nub Inc. The mechanism on how the product being transferred into the box is by utilizing the force of gravity. This is the video on how the product being transferred into the box by utilizing the gravitational force. The product transfer along the bottle conveyor, and as you can see at the bottom of this machine, in this next preview, it will show to you the product fell down into the box by the gravitational force. In this slide, I will show to you the process of the bottling production line. First, the water treatment process. Next, the fabrication of the polyethylene bottle through the blow molding process, and then the water filling process, and after that the labeling process, and lastly the packaging process. The literature review which are related to this project. First, according to the ABDULLAH et al. 2015 in the automated packaging machine using PLC, packaging process is known as the mechanism that is intended for distribution in form of merchandise, packaging, and bundle into the container, package or protect the material, food, and wood with the utilization of a conveyor belt system. Besides that, packaging process, also known as the system for preparing products for shipping, storage, logistics, and eventually for customer. Next, according to Satyanarayana Murthy 2019 in Design of Controller for Inspection, Packaging and Storage, the benefit of utilizing the automatic packaging machine in the production line are: it will meet the industry and consumer demands. Next, it will maintain the package safety, and lastly, it will reduce the environmental effects. There are three main parts in the automatic bottling packaging machine. First, the input device, controller, and output device. The literature review which are related to the input device are, according to the Oladapo et al. In Model, Design and Simulation of Automatic Sorting Machine using Proximity Sensor, a sensor that detects the presence of an actuator product is referred to as input device. Next, according to Rahman et al. In automatic sorting, counting and bottle filling machine, input device can be known as the converter that measure physical change and converted it into signal which can be read by controller. For the controller can be known as the component that interprets sensor data and sends signal to the output device. According to Saraf et al. In design and development of cost-effective automatic machine for powder packaging, controller can be classified into three types, which are relay controllers, programmable logic controllers or PLC, and lastly microcontroller. For the output device can be known as the component that receive the controller electrical signal and converted it to the mechanical energy. According to Figliolini and Ria in design and test of pneumatic system for production automation, in the manufacturing industry, pneumatic and electro-pneumatic components are used to solve problems in product and automated process. For the input device of this project, input device of proximity sensor has been utilized in the automatic bottling packaging machine. Proximity sensor is a non-contact sensor which detects the presence of object and convert it into electric signal. The utilization of the proximity sensor utilize the change in electromagnetic wave. Here, as you can see here, this is the electromagnetic wave to detect the presence of object. For the controller part in the automatic bottling packaging machine, it utilizes the PLC. According to Mozhi et al. In PLC controlled automatic food packaging machine, PLC can be known as electronic device with programmable memory that stores instruction and scan the input memory and output predictably. And according to Saraf et al. In design and development of cost-effective automatic machine for powder packaging, the benefit of utilizing the PLC in the industry it has the various input and output arrangement. Next, it has resilient to vibration impact, and lastly, it is wide temperature range. There are three types of actuator which exist in the industrial sector. First, the pneumatic actuator. Second, the electric actuator, and lastly, the hydraulic actuator. The advantage of utilizing the pneumatic actuator is it is high safety, it has the cheap price and fast response, while the drawback of utilizing the pneumatic actuator is it has the poor stability. For the electric actuator, it has the large output thrust and high stability, and the drawback, it requires a professional technician to maintain the actuator. For the hydraulic actuator, the advantage of utilizing it is it has the large output thrust and it will have the stable operation, while the drawback of the hydraulic actuator is it is expensive and it requires a large volume of hydraulic liquid. This is the pneumatic actuator, the electric actuator, and lastly the hydraulic actuator. For this project, the automatic bottling packaging machine will use the pneumatic actuator. This is the assembly process in the SolidWorks software. The reason why the assembly process must be conducted in the SolidWorks is to ensure the part accessibility and to ease the product simulation. In the assembly process, there is a mate feature. The mating feature is critical to ensure that each of the component is linked and will not be moved throughout the whole simulation process. In this slide, I will explain to you the working principle for the automatic bottling packaging machine. First, the mineral water bottle will approach toward the proximity sensor 1, and it will trigger the actuator 1 to extend, and then 4 mineral water bottle will be pushed inside the top rack, and after that the actuator 1 will retract. The operation 1, 2 and 3 will be repeated until the top rack will be filled with 24 mineral water bottle. Next, after the 24 mineral water bottle fill the top rack, the proximity sensor detects the approach of the mineral water bottle. Here it will detect the mineral water bottle and trigger actuator 3 to extend. Therefore, the extension of the actuator 3 will cause the box will be pushed towards under the top rack. After that, the extension of the actuator 3 will trigger the actuator 2 to extend. The extension of the actuator 2 will cause the 24 of mineral water bottle will fall down into the box with the gravitational force. In this slide, I will show to you the step on how to conduct the motion analysis in SolidWorks. First, select the SolidWorks motion at the top of the SolidWorks taskbar, and then select the motion analysis. Next, I will show to you the next step of the motion analysis, which is the adding motion analysis feature such as motor feature, contact feature, and lastly the gravity feature. After finally we have select the desired motion analysis feature, it will turn out to be like this. It will show at the tree at the left side of the SolidWorks interface. Next step is adding sensor process in the motion analysis. First, select sensor and click the add sensor from the pop-up menu, and then it will turn out like this. You must select the place where the sensor is placed in the design, and after that the sensor will be looked at like this in this figure here. In this slide, I will explain to you the arranging process in the motion analysis. First, mineral water bottle, which are labeled as B1, B2, B3, B4, B5 and B6, was set to move with speed of 50 mm per second or 0.05 meter per second on bottle conveyor. Next, the proximity sensor 1, as you can see in the figure shown at the arrow, will detect the approach of P1 in range of 3 mm, and after that the actuator 1, which is labeled as P1, extend for 127.5 mm in 0.5 second. After that, P1 will retract for 127.5 mm in 0.1 second. The process of 2, 3 and 4 as shown in the text box will be repeated with B2, B3, B4, B5 and B6 until the top rack will be filled with 24 mineral water bottle. Next, proximity sensor 2 will detect the approach of P1 in range of 30 mm. This will cause the actuator 3, which is labeled as P3, will be extended for 276.27 mm in 0.5 second. After that, the process of simulation continue with the 3 second of delay, and then the actuator 2, which is labeled as P2, will be extended for 30 mm in 0.1 second. As you can see at the arrow shown in the figure, the P2 EXT is the actuator 2 extend, and after that 24 mineral water bottle will fall into the box with the gravitational force. From this project, we can find that the design of the automatic bottling packaging machine is designed. Here is the two point of view of the automatic bottling packaging machine from the front side and the back side. In the design of the automatic bottling packaging machine, the utilization of proximity sensor is 2, while the pneumatic actuator is 3. There is also the top rack as shown here, and the bottle conveyor here, and lastly the box conveyor. Here is the assembly drawing of the design for the automatic bottling packaging machine, which is generated from the SolidWorks software. The major dimension is 1175.57 mm. The length for the packaging machine is 933.94 mm, and the width for the automatic bottling packaging machine is 1163.15 mm. Thus, the dimension of the automatic bottling packaging machine not exceed the existing available at the packaging section, as the final available space in the packaging section floor plan will be the new length to the office will be 699.06 mm, and the new width to the wall from the packaging machine is 26.85 mm. Here is the simulation of the automatic bottling packaging machine, which is generated from the SolidWorks software in the feature of the motion analysis. You can click in the link here to proceed to the YouTube where I have posted the video. I will show to you in this slide the operation on how the bottle will be transferred by the machine into the box. Firstly, the bottle will approach the proximity sensor 1 and it will trigger the actuator 1 here to extend and retract back, and the process continue with the bottle at behind the bottle has been pushed by the actuator. The process continue and repeated until the 24 mineral water bottle fill the top rack, and after that the bottle will be fell down into the box by the gravitational force. This is the close-up version of the simulation. As you can see here, the actuator push and retract as it is been triggered by the proximity sensor 1 here. And after the process of filling the 24 mineral water bottle in the top rack, it will push first the actuator 3, where the box will be pushed here, and then after that, as you can see before, after the extension of the actuator 3, it will trigger the extension of the actuator 2. We will be moving on to the analysis of the simulation. According to the simulation, the total process of the simulation conducted by the automatic bottling packaging machine is 38.5 seconds. The duration was been taken by using the speed of the bottle conveyor, which has been set for 0.05 meter per second or 50 millimeter per second. Thus, if the speed of the bottle conveyor was set to 0.15 meter per second, which is the same of the exit speed of the bottle conveyor at ESSB, the total time taken to complete the packaging process will take 12.67 seconds. As you can see here, this is the comparison of the time taken between the time which is taken during the site visit at ESSB, which take about 16 seconds, and the analysis from the simulation of the automatic bottling packaging machine. This shows the analysis from the simulation is much faster than the time of the manually packaging by the human operator at the plant. Then the processing time will be increased to 20.8%. In this slide, I will present to you the comparison between the production which is produced by the ESSP and the new production which is simulated via the motion study in the SolidWorks. For 1 minute, 3 boxes will be produced by ESSP, while in 1 minute, 4 boxes will be produced by the automatic bottling packaging machine via the motion study simulation. And for 1 hour, 225 boxes will be produced by ESSP, and for 1 hour, 284 boxes will be produced by the simulation in the motion study. For 1 day, in the 8 hours of working hours, 1,800 boxes will be produced by ESSP, and 2,273 boxes will be produced by the simulation of the motion study of the automatic bottling packaging machine. For 1 month, in the 26 days of working days, 46,800 boxes will be produced by ESSP, and 59,100 boxes will be produced by the new production via the motion study in the SolidWorks. The difference between the new production and the existing production at the ESSP is shown in the table here. Therefore, the productivity can be calculated from the number of boxes stated in the table above. Therefore, the productivity for 1 minute will be increased to 33.33%. For 1 hour, the productivity will be increased to 26.22%, and for 1 day in 8 hours of working, the productivity will be increased to 26.28%, which is same as the productivity produced in 1 month of 26 days of working days. The originality of this project is the design of the automatic bottling packaging machine can convert the manual packaging process into the automation process. Second, the employing of the automation process in the production can enhance the automation process, where it will reduce the human interference. And lastly, the reduction of employee, labor cost and processing time, and the increase of the production of the mineral water bottle to the SME company such as ESSB. Lastly, for conclusion, the project has attained the goal of designing and simulating the automatic bottling packaging machine. Next, the utilization of the proximity sensor, PLC controller and actuator as the input device, controller and the output device in the design of the automatic bottling packaging machine. Next, the machine can effectively functioning as the processing time of the packaging process can be increased by 20.8% in 12.67 seconds. And lastly, the productivity for box of mineral water bottle can be increased to 26.28% per month. Recommendation which can be recommended for the future work is the machine ability to various size of bottle, where the current design of the automatic bottling packaging machine is limited to 500 ml size of bottle. Next, the pick and place mechanism of the bottle As you can see here, this is the robotic arm pick and place the bottle into the box. Next, the utilization of the case erector machine in the production line. The case erector machine can automated full the box without the human work, where the whole process of the production of the mineral water can be automated. And lastly, the correct specification of the input and the output device. That's all from me. If you have any question regarding to my project, you can contact me at my number below 01731668829, or you can email me by my email below at manhazeeq@gmail.com. Thank you for lending your ears to hear to my presentation.